Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building solutions on Oracle Cloud. My name is Joey, and I'll be your host for today's session. This is the fifth session of our series on the Oracle Analytics Cloud platform, and will be separated into two parts, machine learning and AI. Today's session will be focused on machine learning, and look forward to the AI section coming soon. This session is being recorded, and you'll be able to find the recording on Cloud Customer Connect. You can also find the recordings and slide deck of our previous sessions there as well. To lead us through today's webinar, I'm honored to introduce our featured speakers, Uma Kumar from our personalized training team, and Pete Medora as our analytics expert. And with that, I will hand it over to Uma.
Thanks, Joey. Hi all. Today we are going to be talking about machine learning in Oracle Analytics Cloud. And to get us started with a brief agenda, I'll be going through another overview of Oracle Analytics Cloud as a comprehensive analytics platform. And then we'll go into the native versus integrated features of machine learning in OAC, followed by a detailed demonstration by Pete to showcase these tools. So for our overview or review of Oracle Analytics Cloud, OAC can be thought of as a comprehensive analytics platform. It provides you with capabilities for self-service, augmented, and governed analytics. So typically we deal with self-service analytics when we talk about visualizations and dashboarding. Today we'll be focusing more on the augmented analytics portion, talking about machine learning, how we can import our machine learning models from different services in OCI and then use the native ML tools within OAC as well. But you can also scale and extend out to an enterprise level with this tool with different roles and also taking advantage of enterprise security and architecture of OAC. So this is a holistic view of the analytics workflow, just shown in this diagram. It begins with your more technical tasks like connecting to your relevant data sources or modeling your physical sources into logical business views. Then it's going to allow for things like data preparation and enrichment. Next, you'll have your more business-centric tasks like exploring data and making insights. This allows you to create visual stories and an experience which you can then share through collaboration with your colleagues. So today we'll be kind of focusing in between the prepare and explore side of OAC. So we'll categorize the training into two different buckets today. We have our native features for machine learning within Oracle Analytics Cloud, and then the integrated features, which will include Oracle Machine Learning and the data science platform. Before we get into the rest of the slide deck, I did want to invite Pete to talk a little bit about why use machine learning and machine learning models in general, and what is the real value of it.
Well, machine learning has been around for quite a while. But as we collect more and more data, we have more and more use cases where ML can be applied. Some of the obvious reasons to build models are around improved decision making and delivering data-driven insights. I mean, we are in OAC, where it's paramount. But what about when you're looking to maybe automate a manual process or improving your security by developing proactive security measures? What if you're looking to boost your competitive advantage by improving operational efficiency and reducing costs? Maybe you're just looking to enhance customer experience by offering better personal recommendations. There are truly limitless use cases out there, and it all starts by identifying a business problem and understanding if ML is a good method for solving it. And that's what we're going to be focusing on today.
Awesome. Thanks, Pete. All right, so now I'll just get started into the native and then we'll go into the integrated side for OAC, but we'll start out with how you can natively work with machine learning in OAC, and that I'll be describing the machine learning lifecycle. So to build machine learning models in OAC, you're going to be utilizing the data flow feature to train your different types of models. So you can choose from a variety of algorithms to create classifier, regression, and or clustering models. The platform is going to allow users to update exposed hyperparameters to help with common tasks like imputation and training percentages. And after you have configured your model, all you need to do is give the model a name and then save and run that data flow. Once the data flow is run and the model has been created, it's going to appear in the machine learning tab within OAC and provide visuals and related data to access model quality. So you can go in, look at the quality, tune the model if necessary, and once you're happy with the quality of your model, then you can go ahead and apply the model to new data by creating a new data flow. That's the overall life cycle, what it looks like in machine learning in OAC, and Pete's going to, again, be taking us through that in more detail. Next, I'm going to talk a little bit about integrating machine learning into OAC. So what if you're building a model using machine learning in the autonomous database or OCI data science? So you can build and train models in different services and then bring them into OAC and apply them to your data using a data flow. So we'll kind of go through that in the next couple slides. The first one we're going to be talking about is Oracle Machine Learning. So this is a feature of the autonomous database, and it provides you with a complete machine learning platform, including Jupyter notebooks and an AutoML option. So any models that you develop in Oracle Machine Learning can be easily registered in OAC by simply making a connection to that database. And then once again, to apply the model, you would run it in a new data flow. The next platform I'll talk about is OCI Data Science. So similar to Oracle Machine Learning, our OCI Data Science platform is going to be integrated with OAC. So the Data Science platform is Oracle's general purpose ML and AI development platform, and it's going to allow customers to select various compute shapes to support their model training requirements. So again, you would access this through a connection in OAC. And then once you have registered your model, you're able to use it in a new data flow to apply to new data. So that essentially is what we're going to be diving into with the native and integrated features in OAC. So at this point, I'm going to hand it over to Pete to take us through the demonstration.
Thank you very much, Uma, and thank you for attending part one of our fifth installment of the series. For the next 40 minutes or so, I'll be covering all the features that Uma just previewed. And as mentioned, we'll break it down into a couple of sections. First, the native ML features within OAC, and then second, the integrated services that OAC can utilize. And just before we get out of PowerPoint, I want to quickly discuss the typical machine learning lifecycle and what we'll be focusing on today. Now, when you're starting a machine learning project, this is your kind of standard order of operations. And really, without having a business case, there's not a lot of purpose in building a machine learning model. So you really always want to start off with what is the business problem? What are you trying to solve? And of course, can it be done with ML? Now, for someone that's new to ML, that might be a little hard to answer if ML can solve their issue or not. But that's one of those things that as you get into more of this discipline, you will learn, what's suited for ML versus maybe what's suited for AI or Gen AI or other technologies out there. Next is really developing a data strategy and collecting relevant data. If you speak to most data scientists, they will say this is 80% of part of their time. Since I'm assuming all of you are OAC users, you focus on data. We all know dirty data is bad for any reports, and clean data is what you should always strive for. But it is even more important when building machine learning models. So building that training data set that represents your data that is clean, that is accurate, that really showcases how your business runs can take a long time, but it is the most important thing in this entire process of building a model. Next is then choosing a model, right? What is the right algorithm? What's the right framework for it? Once you select those, then it really gets to the point of let's train it, let's deploy it. And what does deploy mean? Deploy means you've built a model and it's accessible so other service or services can actually call it to get the outputs, right? To get the answers from your model. And then lastly, you always have to monitor and evaluate your model. Building a model, once you build the model and you deploy it, you are not done. You need to constantly train the data. You need to constantly monitor the model. And this is all part of the standard life cycle of machine learning. Now, where we're going to focus today is mostly in 4 and 5. We're going to talk a little bit about 3 because we do have some integrated tools that can help you choose the suitable algorithm for your data. But we really want to focus more on the features in the services versus standard data science techniques and best practices. And we're certainly not going to get into how to build a perfect training data set because that could take days. So with that, let's get out of PowerPoint and let's get into the demo. Here we are on the OAC home screen. I'm running on the March 2025 Enterprise Edition. Now, as I stated before, we're going to kind of start off with all the native features within OAC. And before I do that, let's kind of talk about the target audience. Who are the users that should be using OAC machine learning features? And I can tell you that they were designed for citizen data scientists that were maybe getting started with machine learning, interested in building some models. And that's why we built it in a drag and drop method. There is no coding in OAC. And those are some of the reasons why users of this might want to move to slightly stronger platforms that offer more capabilities, including custom Python scripting. So it doesn't mean you can't build a high quality model using these tools with a great training data set. It just means there might be times where it lacks some of the features that some data scientists might require, but others, it might work just perfectly. Now, when we're in OAC doing these, as Uma stated, we're going to be primarily using data flows, right? Data flows serve a couple purposes. We've spoken about them in previous sessions, including, I think, intro to data sets. I'm going to pull up an example as a quick little refresher. This is a basic example of a data flow, right? This takes one or more data sources and allows you to add data preparation steps in there, whether you're looking to clean your data, whether you're looking to enhance your data. But at the end of it all, you're going to save your data, right? It is going to produce a new data set. Now, when we're going to be using data flows today, we're going to be using them slightly differently. We're going to be using them to train models that will become machine learning models in OAC. And then we'll also be applying those models within there. And when you apply a model, that does actually produce data, right? Because we want the outputs of the model. So we'll be in data flows for quite a while today. So I just want to kind of level set everyone there. Now, next, let's talk a little bit about the algorithms. I'm going to come back to my home screen. Within Oracle Analytics Cloud, we have pre-built algorithms, right, for different use cases of machine learning scenarios. We have 4 different categories of algorithms: numerical prediction, clustering, multi-classification, and binary classification. Now, I'm not going to go deep into all of these, but ultimately, numerical predictions are, you guessed it, they are producing numbers, right? Whether you're doing forecasts or you're looking at churn or you're looking at anything that's going to produce some type of related number, that's your number prediction. Classification models, they have 2 different modes that we have. One is binary. That is, you are going to produce only 2 relevant answers. Yes, no, on, off, high, low, whatever. 2 values will be produced by a binary classification. And that's actually what we're going to be using today when I talk about the premise. Multi-classification, similar to binary, but can have more. So maybe you need 3 values, high, low, medium, something like that. And then you have clustering. Clustering is an example of an unsupervised model that helps find different little pockets of data using one of the 2 algorithms on the screen. The other 3 are more supervised models where you are targeting the column that you want it to learn on and having it train the model directly on that. So those are really kind of the differences of supervised training models and unsupervised. So our premise today for the model we're going to build is attrition. And the reason we selected attrition is because most people understand it. I didn't want to get bogged down in the data. And I wanted people to focus more on the tools and the functionality. So, with that said, I have a training data set that contains a couple years worth of employee information. Many of them have left the company, many of them are still there, has a nice mix of both. And that is what we are going to build our attrition model on. And again, what's the model designed to do? After we build the model, you would want to apply it to all active employees in the company and then get the prediction to see whether or not the model thinks they are likely to leave the company. So that's the premise for today. Um, Let me go ahead and open up that data set so we can just take a quick look at it. Let's go to data, data sets. We can look at attrition training data set right here. It happens to be in an Oracle database, the training database, but it could be a flat file. And since we are going to be talking about integrated services, I will talk about some of the differences of them. So if I just go into this data set and open it up so you can take a look. Has a lot of your basic attributes that you can imagine that employees have: IDs, first names, last names, departments, job roles, a lot of other metadata. But the column that we care most about is this attrition column. Remember, we have people that have left the company because this is historic data. That's what machine learning is all about. It's about using clean, accurate, historic data to make future predictions. So we want the system to understand attrition, and when the model's created, the model will understand which of the other columns or features, I may refer to them as, impact why someone has left. And then the model will use that intelligence and then apply that to future or current employees, and then, of course, provide a prediction. So let's get into this, and let's actually start building out our first training model. So I'm going to close this. We'll go home, create data flow. Now, like any data flow, you have to start with some data. We're going to say attrition training data set. Now, one nice thing about OAC, here's one of the differences. Any data source that is allowed to be used in a data flow, which is 95% of them, can be used to train data, right? So this just happens to be coming from an Oracle database, this set. And once you have your training data set here, you can do a lot of clean. Let's say it's not perfectly clean, or maybe it's completely raw and you want to clean it up. Well, I'm going to flip back to this example for a minute. You can do all that. You can do all of your data preparation, all of your cleaning, all of your enhancing, and then at the end of this, you can actually train a model. So you can do all that cleaning in the same data pipeline if you wish to, using these data flows. We're keeping ours simple. We're going to say, nope, the training data has been vetted. It is clean. It is ready to build a model off of. So at this point, I can either select this plus sign, get all my options, or of course, I can come down here and select down here. So we know, again, our attrition column has only two values, yes and no. So we are going to select a train binary classifier for this example. These are the different algorithms that can handle a two classification model. We are going to select naive Bayes and say OK. Now I'm going to hide this data panel down below temporarily. So what is this showing you down here? It's basically saying, OK, the model training script is a naive Bayes. What column do we want it to train on? Attrition. And then down here are different hyperparameters that we expose. Now, for each algorithm, we have a different set of hyperparameters. Some are going to be uniform across them, like different ways of doing imputation, whether it's categorical or numeric, doing different percents of training percentages. Those are going to be standard. But just want to show you, if I were to switch to neural network, see, many more hyperparameters exposed. So those are there for you to help configure, tune, and improve the quality of your model. So we'll just switch back to the naive Bayes. We'll keep it simple. We know our column is attrition. We are actually going to keep the defaults. Now, for anyone looking to get more information on these, we do have full documentation online, and that you can basically read up on all these and what they mean and how they affect the quality of the model and the data within there. Once you've selected and adjusted all of your hyperparameters, the next step is just to save the model. So this will save a model artifact right within OAC. And we can call this attrition model, maybe v1.0, and I'm going to put NB for naive Bayes. Because if the quality isn't good on it, I might want to try a different algorithm. Because each algorithm can potentially, they have other different strengths. And some algorithms work better on certain data sets. So sometimes you have to try multiple algorithms to see what's going to work best for you. Now that we've given the model a name, we just have to save the data flow. And this is going to be train attrition model, naive Bayes. We say OK. And at this point, we've now created the data flow. We've saved the data flow. We could run it. And if we run it, then it's going to produce a new model. Now, the time it takes to produce a model depends on the number of columns, the number of rows. So it can definitely, depend on how long, how much data is for how long it's going to take. I don't have a lot of data in here. It usually only takes a few minutes to create a model. Obviously, this might not work when you're in the billions of rows. And that's why we have the other services that we'll be talking about later. So at this point, we're going to kind of pretend that I ran this, and I'm going to back out, and we're going to go to an object I already created before this session. I'm going to go out. I'm going to go back to data. I'm going to go to machine learning, and there is the attrition model, right? This is an example of one I did. It sits here. It's all in the models area. If I right click on it and go to inspect, and remember, inspect is like properties, I want to walk you through the model details and metadata. So first, you have some very basic info, but it also tells you what it's trying to predict, and it tells you what type of model. Because pretty soon, we're going to show you how to register models from other services. So it's good to know, is this an OAC model or some other model from a different service? Next, we can go to quality. Now, we have a built-in quality confusion matrix here that gives you some of the scores and everything. And this is pretty standard. This allows you for false positives, false negatives, see how well you were doing. If you read this here, you said actual values, yes of 20, yes of 20. But then this actual value of no, 29 of them are actually yes. So a couple false positives there. Same thing here with the other predicted values. This actual value is yes. The predicted value is no. So we had 23 of those. So the model accuracy is okay. I probably wouldn't want to put it into production. Might want to refine it a little bit. But this is just one little piece of information within here that allows you to monitor the quality. And we do have some more quality tools in here that I'm going to show in a minute. Next is access. This is who can run the model, right? Similar to every other object in OAC, you can add security to it. Details, this just gives you the basic metadata of the model. It's telling you it was a binary classification. It tells you the algorithm, the input columns that it used to train. Now, input columns are extremely important because whatever input columns were used to train the model, those are the same ones that are required to be able to apply the model to it, right? Because of all those fields went into the model and the model learned how they all affect someone potentially leaving, all of those fields need to be there when you apply the model because it's expecting all those. So it's a good place to be able to come here and double check that if you're looking to build a new data set to use this model against, you're going to need all of these columns. And then the output columns. These are the columns that the model will produce, right? This is why we're doing all the work. We want to know the predicted value. That's going to be yes or no. Are we expecting them to leave, yes or no? And of course, the prediction confidence. How confident was the model that they're going to leave? Plus, we have a few other columns that we can potentially add to the output. And lastly, the parameters. This just shows you the hyperparameters that you selected for that model. Now, lastly, under the Inspect tab, I go to Related. When you build machine learning models in Oracle, we produce a bunch of underlying files to help support the model. Each of these little data sets, you can see generated data. They are all needed to basically support the model, but they host a lot of information. Each of these can also be queried and monitored. So for example, this is a generated data set that helps build a confusion matrix like the one we just saw. I'm going to select it. And what that does is it brings us automatically into the workbook editor and it brings that CSV file. Now that CSV file is tied directly to that model. So if I just grab all of these and I create a table, you can see, and I'll just move a few around. We'll get the model name up top. We know the target. We know the actual, the predicted, the weights, all the scores. And now what if I wanted to, let's bring a pivot on here. And I'm going to say actual, predicted, value. Let me just clean it up a little bit. We'll add a few summations. And this chart is what we were just seeing a minute ago, right within that inspect panel. Now, if you're using this platform, you're most likely going to build several different models. So you don't want to go into the inspect every time and look at the quality and get the stats. You can use these files to have a live monitoring service. And of course, you can add your other models into the same dashboard. So it really allows you to have build a nice set of dashboards for monitoring purposes. So when the quality goes down, so maybe when you have to retrain and just understanding how the model's doing. So all that generated data that supports the models is very powerful and should be used if you're going to use the OAC machine learning models. All right, so now that I'm going to go back here. So now that we know we built a model, right? We have a model object, we can secure it, we can review some of the stats on it. But at this point, I want to be able to apply that model. So, well, you need data to apply it to. And I already spoke about earlier, you need a data set that has all the same input columns. If you don't, the model won't be able to run. So that takes another data flow. I'm going to come over here. I'm going to say create data flow. And I've already created the data set. And I'm going to say it's my active employees, right? Because we built the model. It was built off of historic data. Now we want to apply it to and see how well it does against our active employees. I already know I have all the input columns in here. Now, we're not training a model this time. We're applying a model. And you can see, well, I have a couple models in there. We're going to get to this one in a minute. But here is my attrition model. See, it's the Oracle Analytics model. Going to select it, say OK. Now, let me minimize this. So there are my two output columns. These are the two main output columns right here. Predicted value, predicted confidence. You can give an alias if you want the output to display something differently. We have a few other parameters that you can add to this model, and this will differ based on the model type and the algorithm you select. We're going to skip over parameters for a minute, and then we're going to go down here and look at our inputs. If you notice, everything is matching up. But let's say your column that you want to apply the model to, the names are a little bit different. This actually allows you to map different columns. In case they're named differently, they mapped everything perfectly because the column names were exact. But if they're not exact, you can just come in here and actually let's get job role. And basically it's a little mapping exercise to make sure all of the columns you have are in there. And once you've done that, all you're doing is saving data, kind of like a standard data flow that saves data, right? And then here we could say predicted attrition results. So that will be the CSV that the system creates. And I can once again say run predicted and that's it. All we have to do is hit the run. And remember, these can be put on schedules. Any data flow can be put on a schedule. And not only that, if you have to run multiples of them, that's when sequences come into play. And we talked about this on an earlier session. Sequences allow you to run multiple data flow objects sequentially. And you can set one schedule on a sequence and it can run many data flows. So it can help from a scheduling standpoint. So let's pretend we've run this data flow. And then we're going to go back to our data sets. And we can see here, we have an attrition predicted OAC. Let's go ahead and take a look at this. All right, here's our new data set. Has everything we originally had. Obviously does not have an attrition column because these are current employees, but we do have our predicted value and our predicted confidence. So let's come over here, let's grab a few files, and now let's bring in predicted value. Okay, well, you know what? Maybe we should sort on that. We only want to see the yeses. Okay, so these are all the people predicted to leave based on the model. Well, now I want to see the confidence. Okay, we can sort that. And maybe, you know what? Maybe I just want the top 10. So right there, in a few minutes, we were able to train a model. Again, we had a good training data set. We took a look at the model. We looked at the stats and the quality of the model. And then we applied the model to our data. And here are our predictions. So that is most of what I wanted to show from OAC. And these are most of the native machine capabilities. Now, I just showed you I was able to apply a OAC model via a data flow. There is one other way to do that, and I'm going to show you that right now. I'm going to back out of this workbook, and let's say I have instead of using a data flow to produce a new data set that has the values, what if I just say, let's open up active employees. All right, so I've just brought active employees into my data set. The model has not been applied to this, but anyone that's been in OAC long enough has probably seen this create scenario. This is built to run a model against your data on the fly. There it is. There's our attrition model. And after I do that, look down here. Let me minimize this. Those are our two columns, right? Our prediction and prediction. And it works the same way. Now, it might not be as fast because it's kind of running it on the fly versus giving us a dedicated data set. But without having to run another data flow. So right now it's actually running against all of these real time. And of course, now again, see, it's got to run it all to see how many, all the yeses and nos. We'll filter on that. And we do the exact same thing for prediction confidence. And I'll let the system see this way is a little bit slower, but again, it's one less step, one less data flow. And of course, we'll do the filter, top 10. Let that render. And there we go. Same results we got before. We just didn't use a data flow. So that is machine learning in a nutshell in OAC. Like I said, you can build high quality models here, but it might not have all the tools of a seasoned data scientist, what they would actually want to have. But still very powerful, very useful. I'm going to back out of here for a minute and close some of these tabs.
Pete, quick question. So you mentioned, they might not be like what a data scientist would want. Could you kind of elaborate on that, or why necessarily would somebody want to use another service other than OAC to build machine learning models? Like if they're just going to pull them into OAC anyways, why not use what's like natively there in the data flow?
Yeah, great question. And from what I found is most data scientists, especially coming out of school or have been out of school for a long time, they're used to coding in Python. They are used to Jupyter notebooks. They are used to Conda environments. They are used to Python libraries. That is kind of the standard. That's what they get trained on coming out of college. That's what you get trained on now if you were to take courses. So that is they're more familiar. They have more control, obviously bringing in any Python libraries they want. So they will typically trend toward that type of service. And that is why we kind of say with OAC machine learning, it's built for citizen data scientists that are maybe a little bit new, still want to try it out. Like I said, you can still build high quality models, but it might not have all the features for a seasoned data scientist. And that is actually a good spot to move on to the integrated. But before I do, I've mentioned this in several other previous sessions, but I can't leave here without talking about the auto insights really quickly, which is running machine learning. I'm going to open up a data set. I have already tagged it, so auto insights will run on it. And of course, these are our auto insights. I'm not going to spend too much time on here. Just a quick reminder that auto insights look at your data holistically. And basically, after a few minutes of looking at it, it's running a bunch of different machine learning scripts in there and it's trying to find correlated data, what might be most important to you. And we'll just let this finish now. And there we go. So it is looking at this data right here, happens to be a different data set. I should have used the attrition one. But at any time, you can use these insights to get started. You can select any chart to add to your canvas automatically. And what I like most about this is you get to direct the data that it looks against. Meaning, you can configure it. Maybe you don't want certain types of visualizations. Maybe I don't want box plots or distributions. And for measures, you can have only 3 at a time, but maybe I care more about profit and quantity. I don't care about discount. And you want to take the time to go through these and say, oh, it's looking at state. Oh, I want to look at subcategory too. And you get to run this as many times as you want, and it will continue producing different results based on the data you want and the chart types. So extremely powerful. Again, I've went over this in previous sessions, but when we're talking about machine learning, I definitely need to bring this up as far as native OAC features. All right, moving on to integrated. Let's close all this. I'm going to open up another workbook just to talk about the 2 other services when we talk about integrated. And they are our machine learning service. It's called OML. As Uma said, it lives within the autonomous database. Within this service, you have Jupyter and Zeppelin notebooks. You can edit. We have editors for SQL, PL SQL, Python, and R. We have a very powerful AutoML feature, which that is actually going to impact OAC. So hold on tight for that one. I'm going to come back to that in a few minutes. You can build Conda environments here. You have data and model monitoring for drift. And you can deploy these to a REST endpoint. There's another difference. OAC machine learning models can only be utilized within OAC. They cannot be called or accessed outside of OAC. Where models built in Oracle Machine Learning, they can immediately produce you a REST endpoint, so any service that can access them can utilize them. So a much richer development platform right here, and it's just a feature of the database. Nothing you need to pay for. If you have autonomous database, you have Oracle Machine Learning. Now, our data science platform, this is our general purpose model building service. This is a very powerful service. This is where, based on the volume of data you need, you might be using this service because maybe you have billions and billions of rows and you need GPUs or maybe just CPUs. And this is all available within our data science service. In addition to that, of course, they have Jupyter Notebooks. It's Python based. We provide a very powerful Python library called ADS that helps with most of the standard machine learning tasks within there. So it makes it very easy to type in a few lines of Python to do a lot of work within there. The data science platform also has a much stronger governance and model management setup with model evaluation and comparison and ML pipelines. And lastly, it has a newer feature called AI Quick Actions, and that's for fine-tuning large language models. Again, nothing we're going to get into today, but these tools obviously have different use cases. When your data is already in an Oracle Autonomous Database, the machine learning platform is perfect for you because the data is already going to be parallelized, the data is secure, you're bringing the algorithm to the data. Whereas in data science, That's a serverless offering. And of course, you can connect to pretty much any data source via REST or actually import your own data and still produce, obviously, any type of model, whether it's ML, AI, large language model. You can do lots of things over there in data science. Now, these are the two services that OAC can utilize models from. And that's what I'm going to be kind of walking through next. So that's really the premise that you have data scientists building models in both of these services, and you have your OAC analyst wanting to apply them to their data. So you kind of have a separation of duties, but OAC, you never have to leave OAC to pull in these models. So let's go ahead. We saw the prediction that OAC gave us before, right? It gave us a predicted confidence and a predicted value, the yes, no, and the confidence. I'm going to go into a dashboard here, and this is HR related. Again, we're talking about attrition. Just to kind of set it up a little bit more. This one I built a while ago, and this was all about attrition. So basically, this is built off the same data set. I have a couple other canvases here talking about different areas of HR, but this one is tied to this data model, and it always has the latest attrition review data. So likely to leave. Yeah, I want to focus on people likely to leave. I think I got some filters on here too. And I will reduce some of these. There we go. So we have a bunch of different ones that are likely to leave in here. And when you're analyzing them, you can look at different attributes. And the reason I'm showing you this is, again, the OAC model gave us two prediction outputs. This OML model that this was built on gives us 15 or more different output columns, including model explainability columns. Because down here, you can see here, attribute 1, attribute 2, attribute 3, 4, and so on. The weight of each one. When you're getting a model prediction, sometimes you need more than just a number and a yes or a no. You want to know what went into it. Why did the model say yes? Why did the model give it a prediction? Those extra values that are listed in this output is what gives you that model explainability, which is very important. And this is what one of the models can do in the Oracle database. And this is the model that we're going to produce right now. So we all start off at the exact same way. For an OML model, you of course need to set up a connection. And that is a standard connection to either your autonomous data warehouse or your autonomous transaction processing. I'm not going to set up the connection today, but your standard credentials once you set it up. I do have one set up just to kind of show you what the connection looks like. Very standard. You bring in your wallet, give it some credentials, connect, you're good to go. Now, once the connection is set up and the models have already been built inside Oracle Machine Learning, all you need to do is set up a connection to that database and then register the model. To register it, you come up here, register model function, you select machine learning models. Right here, it's going to say, well, which connection do you want to use? Well, I'm going to use my ADW23AI. And we're going to let it query for a second. I think I selected the right one. Let me try this one. There we go. Wrong one. A couple databases out there. These are models that have been sitting or that are sitting in the Oracle database, in the Oracle machine learning platform, right? These are a bunch of different models, all related to attrition. I can select any one of them. It can tell you, look, yep, this was an attrition model. It tells you the algorithm, the model class, of course, the input columns. Look, a lot less input columns in this one, right? Didn't have 20 of them. I'll explain that in a minute. Output columns. Now look at those number of output columns. That again helps with model explainability. And then of course, the parameters that were done. So obviously you can compare models against other models. Sometimes you need to tweak the hyperparameters to, adjust the quality of the model. So at any time, I can say this is going to be Pete's OML attrition model. And I say register, and immediately I come over to machine learning. There it is. If I go and inspect it, see now look, it's no longer an OAC model. It's autonomous data warehouse model. So it is an external model. It is attrition. Same thing with security. Same thing with details. Related are slightly different. When you build models in OML, the related data underlying it are built in the form of views in the database. So within OAC, you could easily create a data set to any of these view names that are now all available because that model exists. And this is how you would monitor the model if you're going to do it directly from OAC. So there's a whole host, a lot of great information in these different views to help understand how the model's working, the scoring, the quality, and so on. So that is still pretty similar. And to apply the model, it's still similar. You do it through a data flow. So if I come over to data flow, we are going to say my active employees. And I'm going to say apply model. Of course, see, it shows that one that I just registered. It's got this one down here. I forget which one this one is, but we'll use the new one. Now, immediately, look at all the additional outputs. This is kind of what I've been showing you. This is one reason to potentially want to use the autonomous database, OML service. So I'm going to get all these outputs for every row. That means for every single row in here, I'm going to get the top 5 attributes, the weight and the value of them to understand why one drove one in a different direction. And the process is still the same over here. We want to save the data. Now, a couple differences between applying a model within OAC and within OML. In OAC, you can apply a model to any data set. When using OML, you need to apply it to a data set in the same database where the model resides. So that is something very that you need to keep be aware of. So the model and the data set you're applying it to need to be in the same data set. And lastly, when you save the data, it is automatically the results are going back down to the database. It is not going to produce a CSV like in OAC. So those are just some differences here when you're going to run these. So if I were to run this, save this, it's going to produce a new data set. I can give it any data set name, any table name I want, as long as it follows the rules. And let's go take a look at that. And if I go back to data, and there's my attrition predicted. Let's go and take a look at that. Oh, this was one that was done on the OAC one. Let me try to get a different one. I think I have one. Let's try. Well, I didn't run it. Let's actually run it right now. So we're going to say data flow. We'll just repeat this so we can see the predicted file. Thought I had one available. We're going to say active employees. We're going to say apply model. And then we're going to say save data. Predicted attrition, DB. Apply OML model. We'll run that. And while we're running it, we're going to kind of move on to another topic, and that should appear in a few minutes. And I can back out of there while it's still running. Now, one other thing I need to talk about, I don't want to go into other services because I want to keep this OAC centric, but there is a feature in the Oracle database. And if I come back here and I go to my little cheat sheet, it's called AutoML. And the reason I'm going to talk about this for a second, this AutoML allows a user to select their training data set, select their target, and select a metric a scoring metric, because there's multiple scoring metrics that a model can have. They can select a scoring metric that they want the platform to focus on and tune to. And what AutoML does is it will run through all algorithms. It will basically do an algorithm selection. It will do feature selection, meaning determining which columns and features heavily correlate to the target that you're trying to learn on that should be included in the input data. It will do sampling and it will do hypertuning all by itself. And this AutoML capabilities are very powerful. And immediately within, a few minutes to an hour, it can produce 8 to 10 models. And it even ranks the models, which ones are the best models based on the score that you selected. All done, nothing else you need to do. You don't need to know any Python. You can, of course, take them from there and open up a Jupyter notebook and modify it. But the reason I'm talking about this is this AutoML feature can be utilized directly within OAC. So if I come back here, and I'm going to go to data flows one last time, we're going to go to create. We're going to go to data flow. I am going to say my active employees. And immediately when I hook it up to an Oracle database, this AutoML feature pops in there. So, oh, I'm sorry. This is for training. I apologize. So when I basically the AutoML is to train, not predict. So if I go back to and I say attrition training data set, and then I say AutoML because it's sitting in the database, it says, what column do you care about? Attrition. It immediately knows it's going to be a classification model, and then you get to select what metric you want it to focus on. We'll keep balanced accuracy. Once we save the model, what it does is it utilizes the database's OML, AutoML engine. It will run all of the algorithms possible against your data set, and the top scoring model, it will automatically register and produce for you in OAC. So you never have to even open up the database, and you can still utilize that OML feature directly from OAC. So another great advantage for people that are maybe new to data science, but also have an ADW, that's something you really want to be able to take advantage of. All right. So I just want to do one more thing, and then we're going to wrap up today. I also want to show you a connection on the data science. So for data science, it's slightly different. You're not making a database connection. You're making what's called a OCI resource connection. And I'm going to get out of here. I'm going to go to connections, and right here, OCI resource. Now, I don't want to get into this too much, but there's two methods for this OCI resource. This connection allows you access to multiple AI services that will be focusing on part 2 of this series. It will allow you to have access to functions which you can run Python scripts in, and it will give you access to your data science platform and Oracle Object Storage if you want it. And you have two modes for setting up a connection. You can tie it to an individual user, and you just have to grab some information in OCI to set this up, or you tie it to what's called a resource principal, and there's all documentation out there. And basically, you're tying the ability to use other Oracle Cloud Infrastructure resources, and you're tying it to the OAC app, not to a user. That is the preferred method. And for each connection, see here, I could set up one connection just for data science, or I could allow this connection to call any of these. Vision, language, and document understanding are AI services. Object storage is our object storage buckets. Function services for running scripts like Python, and of course our data science. So we're only going to be focusing on data science right now, but this is how you would set up the connection. So first you get the connection. You'd have to do some policies in OCI to make this work, or you say the API key, and that's going against a specific user. I do have one of these working. So if I say register machine learning models, and I use my access to AI services, Oops. Here is a model. Oh, nothing here. Thought I had some. That's maybe. Oh, I thought I had some more in here. But essentially, when you come in here, let me try one more. No, I think let's switch to one other service really quick. So I just want you to be able to see the connection getting set up. I'm going to go to, again, register machine learning model. I am going to use my OCI resource connection, select a compartment. There we go. So when you try to register a data science model, there's a slight difference. So when I come in here, you can see all the model predictions. You can see the input, the output, you can give it a name. But most importantly, you get to set the shape, right? So when you kick off the job, you might need CPUs. You might even need GPUs. So when this job kicks off, you're going to select the shape of the compute that is going to run your model. And it allows you to do this when you register it. So obviously you might need to register some on different compute shapes if you want. But this is the practice for registering a data science model. Okay. Now, that was, I think, everything we wanted to cover within here. So we covered machine learning native features, right, to be able to build an OAC. We showed you some that you could register and utilize from other services that have other capabilities that aren't included in OAC. And we obviously covered the auto insights. So with that, I just want to say thank you to everyone who attended. And as always, I hope this was a good use of your time. I want to say a big thank you to Uma and Joey and the entire team that helps put these sessions together. And a quick reminder, our next session is going to be part 2, all things AI native and integrated within OAC. And with that, back to you, Uma.
Thanks, Pete. Okay, so just going through some key takeaways today. Pete pretty much covered it all. We talked about the native machine learning within OAC and the machine learning model lifecycle, and then discuss how to bring in models from other OCI services like OML or OCI data science. So I'll hand it to Joey to take us through some next steps about the session and the program.
Awesome session. Thank you, Uma and Pete. Really appreciate your time and help with this session. I hope it was a good learning experience for everybody who is here to watch. If you would like to learn more beyond just these Day 1 and Beyond series, we have some different links here on the screen that will be shared out as well, along with the recording when it is uploaded. You could go to Oracle University to get certified and some other guided trainings there as well. You could get hands-on experience with Oracle Cloud by going and downloading or signing up for an Oracle Cloud free tier account or accessing some labs that we have through our Live Labs platform. We also have some videos beyond Day 1 and Beyond on our YouTube channel as well. And if you enjoyed this session and would like us to conduct personalized training sessions for your organization, you can email us at our personal training email and we will reach out to you. We also conduct hands-on labs, which we have in our newly designed QuickShot Live Labs series. And that will be for a more expedited hands-on learning session towards a particular topic. And then finally, we have the Code Innovate program where we can co-develop solutions with you based off of your use cases. But please remember that personal training is an investment that we make to our customers to help them grow and develop their skills on OCI with no cost to them. And here are some of our other series that you can tune into. We have our core series, the Oracle Analytics Cloud series, which you have just listened to a session on. We have the hands-on series, the Cloud Native Launchpad, the Cloud Security series, and the Did You Know series to let you know what's new in OCI. As mentioned, look out for part 2 on AI and OAC to be uploaded to YouTube channel soon. And our next live session will be semantic modeling on OAC on June 2nd. We hope to see you there.